Okay, so today we're going to go over solving quadratics by algebra again. This is day 2. This time we're going to look at imaginary solutions. Okay, so solving quadratics by algebra day 2. So we want to isolate the quadratic term. So we want to isolate just the x squared. So we have to undo the adding one, and we also have to undo the multiplying by 4. So we have to undo both of those first. So we're going to subtract 1 first, and that's going to leave us 4x squared equals -1. Then we're going to divide out the 4. So you have to divide out the coefficient first. So you have to make sure that you isolate the quadratic term first. Then we can undo the squaring by square rooting. So now we're going to take the square root of both sides. And remember, when you undo a variable that's squared, you have to have that plus and minus in there. So you got to make sure you don't forget that. If we off to the side, right, doesn't this mean the square root of -1? Oopsie oopsies, oopsies oopsies, erase, erase, erase. So that means the square root of -1 over the square root of 4. And didn't we learn that the square root of -1 is I for imaginary, and the square root of 4 is 2. So our answer is I over 2, plus and minus. Or you could write that as 1 plus or minus 1/2 I. So both of those answers are correct. So those are 2. So let me erase, get that out of there for a second. So what kind of solutions do we have? We have 2 answers. So we say we have 2 solutions. And then these are called 2 imaginary solutions. And so if you were actually to graph this parabola, if you were to actually graph 4x squared plus 1, what you would find out, because remember we said that the solutions are the x-intercepts? Well, the fact that you have imaginary solutions, that means that this parabola is not going to cross the x-axis at all. So this parabola has no x-intercepts. That's why it has no real solutions. It only has imaginary solutions because there are no x-intercepts, right? So just FYI that if you were going to graph this, the fact that there's imaginary solutions means that there would have been no x-intercepts. The parabola does not cross. Okay, so let's look at number 2. In number 2, again, we want to isolate the quadratic term. So all of this is the quadratic term. So we want to isolate the quadratic term. So we have to undo the adding 6 by subtracting 6. I hate when I grab the wrong tool. And that's going to give me the quantity x minus 5 squared, excuse me, equals -8. Then I can undo the squaring by square rooting, right? So I'm going to undo squaring by taking the square root, because those are inverse operations. And squaring and square rooting undo each other. And that gives me x minus 5. Actually, I don't need the parentheses anymore. X minus 5 equals... And then because I undid a variable being squared by taking the square root, then I have to apply the square root property, which says I have to have plus and minus. And shouldn't we know by now that the square root of 8 is 2 square root 2? And isn't that true because isn't the square root of 8 4 times 2, which is square root 4 times square root 2, which is why we get 2 square root 2. So you must always simplify your radicals. And then we're going to add 5 to both sides. And my final answer is x equals 5 plus or minus 2 square root 2. Be careful, because what some students do is they forget to put the plus and minus right here. And so sometimes they don't have it there and they try to slap it in at the last minute. So then they do something like this, and then they go 5 plus 2 is 7 square root 2, and then they just slap it right in front. Or, things like that. So you want to make sure that you're putting in that as soon as you use that square root, you want to get that plus or minus in there right away so that you don't make those mistakes. You don't want to wait until the very end and then just kind of slap it in there. You want to make sure that you get it in there as soon as you use the square root property. You want to get that in there right away. So again, your final answer would be 5 plus or minus 2 square root 2 would be your final answer. Oh, do you notice something? Did I forget something? Ha, I caught something. Isn't this a negative square root? So when we have a negative square root, I shouldn't have written square root of 8 over here when I was doing my little sidebar work. I should have written the square root of negative 8. So isn't that the square root of negative 1 times 4 times 2? So isn't the square root of 4, isn't that where 2 square root 2 came from? And isn't the square root of negative 1 my I? So this should actually, I could put the I in the back, or I could put 5 plus or minus 2 with the I in the middle. Sometimes I prefer it this way. You should know both. You don't have to put both. Sometimes I don't like to put the I in the back because if my radical symbol goes too far, it looks like the I is under the radical, which is definitely not correct. So that's why sometimes I don't like writing it in the back. But so either one is fine. Just make sure if you're writing the I in the back that it's definitely outside the radical. Okay, now we're on problem number 3. Remember, we want to isolate the quadratic term first. So you've got to isolate the quadratic term, which means we have to divide by a negative 6. So I'm going to divide by a negative 6, and that gives me x squared equals 25 6. So negative. You can put the negative wherever you want to put it. You can put it in the middle. You can put it up on top. You can put it at the bottom. And then we can use the square root property. Take the square root to undo the variable being squared, and that negative belongs inside the square root. So let me go back and fix that. So it's negative 25 over 6. And so x equals, got to get that plus and minus in there right away, and then off to the side. Doesn't that give us a negative 25 square root and then a square root 6? And so isn't the square root of negative 25, doesn't that give me a 5i in the numerator and then a square root of 6 in the denominator? And then remember, we can't have a radical in the denominator, so we're going to multiply by that fancy number 1. So aren't we going to multiply top and bottom by square root of 6? And so when we multiply these fractions, remember, don't you multiply the numerators together? So when you multiply 5i times square root 6, that's just going to give you 5i square root 6. And when you multiply square root 6 times square root 6, that's square root 36, which is just 6. So my final answer is 5i square root 6 over 6, or it could be written as plus and minus 5 6i square root 6, or you can put the I in the back too, right? So you can put the I in the very back too. So either way. So either one of those answers is good. Okay, let's look at number 4. I think 2 more to go. Okay, number 7. So once again, we want to isolate the quadratic function, the quadratic part, right? So we have to undo adding 3 by subtracting 3. Ay, oy, as Grandma Vera would say, right? Then 7, 3x plus 6 squared equals negative 63, right? Then we have to divide out the 7, and that gives me 3x plus 6 quantity squared is how you read that. And then negative 63 divided by 7, that is negative 9. Now we can undo the squaring by taking the square root, because those are inverse operations. So it undoes it and leaves you just 3x plus 6. And remember, when you undo a variable that's squared by taking the square root, that's why you have to have that plus and minus. And isn't the square root of negative 9, isn't that 3i? Right? Then we can subtract 6 from both sides. So that's going to give me 3x equals negative 6 plus or minus 3i. And then we're going to divide both sides by 3. And that gives me x equals negative 6 plus or minus 3i over 3. And you might think we're done, but we're not. Oh my God. Because if you can reduce, you have to reduce. So to reduce or not to reduce, that is the question. If all three of these have something in common, you must reduce. So they are all divisible by 3. So we can divide each one of those by 3. So if we divide each one by 3, wouldn't that give us 3 goes into negative 6, negative 2 times, plus or minus 3 goes into 3 once, so it'd just be 1i, and 3 goes into 3 once. And obviously, if you're dividing by 1, you shouldn't leave your answer like that. Isn't any number divided by 1 just that thing? So wouldn't my final answer be just negative 2 plus or minus I would be my final answer. So here you have two imaginary roots. You have negative 2 plus I is one of the roots, and negative 2 minus I is the other root. So you have two answers and you have two imaginary solutions or roots. We wouldn't call them x-intercepts because if you have imaginary solutions, that means if we were to go back and graph this, we would find out somewhere that it would never hit the x-axis. So there would be no x-intercepts. I know that there's no x-intercepts because I got imaginary solutions. So they're still solutions, but they're not x-intercepts. So they're still solutions. They're not really the zeros. They're the roots. But we kind of use those words kind of interchangeable. Roots, zeros, solutions, x-intercepts. But here there would not be any x-intercepts, right? Because they're imaginary solutions. And you can just leave your answer this way, it's fine. Or you can write them out separately. Just wanted to emphasize that. What's the other thing I wanted to emphasize? Oh, if we go back to reducing, let me show you another way. So I said if all three of them have something in common, you must reduce. We reduced by 3, right? So we divided each one of these by 3. That's how we got this. And then from there, we got our final answer. But I want to show you the other way of looking at it. So the other way of looking at it would be if I have this answer, let me erase some more. So remember, your solutions are your x-intercepts if you were to graph it. If you have imaginary solutions, that means there would not be any x-intercepts. So here we have x equals negative 6 plus or minus 3i divided by 3. So the other way of doing it is in the numerator, couldn't we factor out, right? Couldn't we factor out, say, a 3? And if I factor out a 3, wouldn't that leave me 3, negative 2 plus or minus I? If you factor out a 3, and then doesn't 3 divided by 3 equal 1? And so isn't that why, another reason why it would give you that? So you could have factored out in the numerator a 3, or you can just think about if all 3 have to have something in common in order to reduce, because technically we're factoring out a number and then it would have something in common. Okay, so I think that's it. It's just a short one today because we've already covered how to solve using algebra. Oh, nope, we got one more. Look at that. Got one more sitting there. Okay, one more to go. So here we have this equation, and don't we want to get everything, all the quadratics on one side? So sometimes if you're unsure, you can put everything on one side and then kind of analyze it. So if I added 3x squared to both sides, right, it makes sense to put all my x squareds on one side. That gives me 4x squared plus 3 equals negative 45. And so for this particular problem, I don't necessarily really want to put it in standard form because my goal is to isolate the quadratic term. So I have to undo adding 3 by subtracting 3. That gives me 4x squared equals negative 48. And then I can divide both sides by 4. And that gives me x squared equals negative 16. Then I can undo the squaring by taking the square root. And remember, when you take a square root of a variable that's being squared, you have to have plus and minus. And isn't the square root of negative 16 4i? So that just equals a positive 4i and a negative 4i. So you have two imaginary roots. So once again, if you were to graph that, that means the parabola would not have crossed the x-axis. There would be no x-intercepts, right? There are no x-intercepts because they're imaginary solutions. Okay, that's it for today. So go back and look at the first one if you're completely confused. We did a video earlier on solving using algebra and the square root property, but they didn't have any i's in them. They didn't have any imaginary answers. Okay, ciao, ciao. So I thought I would leave you with just a few seconds of all the problems worked out so you can kind of see all of the problems worked out 1 through 1, 2, 3, 4, 5 problems. Okay.